So you guys are on the warm-up on your own, parts A and B. Being honest with everybody, this is basics here. This is the basics. Sine, cosine, tangent. All right, part A. I just want to know the ratio you used. Don't give me the answer. That's going to be somebody else. What ratio did you use to find part A? All right, here we go. Ones, Makai, what ratio did you use here? Darn right you did. Cosine. Take a look, everybody. We should have used cosine. 54 equals 4.5 over x. Cross multiplied, rounded to the nearest tenth. And we ended up with, we'll get there, baby. Finley, there we go. 7.7, good. All right, quick comment before I ask you how you did part B. If you use that 7.7 in part B, or anytime you use a previous answer in a new question, you got to use the unrounded version. All right, so if you decided to use, let's say, Pythagorean theorem to find y, which would have been correct, make sure you use the unrounded version. All right, don't use 7.7. All right, so going to part B, I don't care how you did it, just let me know though. How'd you do part B? What'd you use? Here we go, Simon. Good job, good talk. Maybe tomorrow. Here we go, Jared. What'd you use? Tangent, fine. So Jared didn't use the 7.7, didn't need to worry about the unrounded version. So we use tangent of 54. I'll use y this time over 6.2. And what do we get rounded to the nearest tenth for this one? All 22 of you here. Dylan?
Which question?
Part B.
I got 6.2.
Yes, you did. 6.2. All right, all good. So again, everyone good on that, especially when it comes to like a part A, B, C question. If you use a previous answer, make sure you use the unrounded version. All good. All right, here's what we got to do today. I'm surprised no one's asked me this all unit yet. If you flip through all the sine, cosine, tangent problems we've done, I've always asked for a side. Every single problem. Find this side, find this side, find this side. Never have I asked to find an angle, and that's what we're going to do today. How do I use sine, cosine, tangent to find an angle instead of a side? And the answer is we're not doing anything different until the very, very end of the problem. All right, we are not doing anything different than what we've done until the very end. So take a look at number one here. We're looking for angle X. We know it's going to be less than 90, so keep that in the back of your mind. All right, identify what the 12 and the 24 are. We're still going to be doing the same thing. But when I say identify, opposite, adjacent, hypotenuse. All right, identify what the 12 and the 24 are. We're not doing anything different yet. Jonathan, here we go. What's the 12? Oh, no. I just want to know. We're not getting that far yet. What's 12? Opposite, adjacent, hypotenuse to x. Adjacent, how about the 24? Hypotenuse, so I can use cosine. Everyone agrees this is cosine. All right, so set it up just like we would. Cosine, but now instead of putting a degree measure, we're going to put x, because that's the angle, equals, what ratio are you going to put over here? 10. Henry, what's going to go on the right side? 12 over 24. Has anything changed yet? Okay, everybody stop, because now it is. It's going to change now. We don't cross multiply. Okay? When we find an angle, we do not cross multiply. All right, because you're going to run into problems. All right, you're going to cross multiply, and you're going to be like, what the heck do I divide by? We don't cross multiply. Here's where it becomes new. We go back to our calculators now. All right, we need to figure out on the, ready? Here's what we're going to figure out on the calculator. What angle has a cosine ratio of 12 over 24? Your calculator knows. All right, so how do you ask your calculator, hey, what angle has a cosine ratio of 12 over 24? Go back to your cosine button. Do you see what's above it in yellow? The A cosine? That's how you find the angle measure. All right, you're going to ask your calculator, ready? Shift cosine. And this thing called arc cosine comes up. Hey, what angle has a cosine ratio of, plug in your ratio, so you can tell the calculator what your ratio is, 12 over 24. So that's what you're asking your calculator right now. What degree measure has a cosine ratio of 12 over 24? Enter, and it'll tell you the angle measure, 60. So that's what we're going to use to find an angle going forward. No cross multiplying, shift, sine, cosine, or tangent. So 60 degrees. All right, one doesn't make you great. Let's go to 2. Find angle x here. All right, what sides am I given with the 12 and the 18? What sides am I given here? Going deep. Good talk again today. Shar, what do you got? What's the 12? Opposite, yep, and 18? Okay. Hypotenuse, so it looks like we're going to use sine here, right? Sine, everybody? Sine x equals, what's your ratio? Just so I know we're all in the same spot here. Shar, again? 12 over 18. I know it's in your blood. Cross multiply. I know it. I get it. All right, but you have to recognize when you find an angle, we don't cross multiply. We go to the calculator and ask it what angle has a sine ratio of 12 over 18. So we go back, shift sine, 12 over 18. Now look, I know it gives us this crazy thing. It just reduced 12 over 18, but this is what we're looking for it around, right? That's my angle measure over here. All right, so don't get freaked out by this here. It just reduced it. 42 degrees. Any questions? Hey, let's bring this back to quadrilaterals now. Rectangle, H-I-J-K. How about we build ourselves a little rectangle? Oh, anybody remember from a rectangle or any quad days? How do I label this? Because you can't just put H-I-J-K anywhere you want. Dylan, what's good? Yeah, clockwise. Don't jump diagonally. So wherever you put H, wherever you start off with H, you got to go clockwise or counterclockwise with the rest of them, not diagonally. Good. All right, what do we got here? KI. So everyone draw in KI. What do we call this, by the way? Thanks. Diagonal, 32. KJ, that side is 11. And everyone see it. Find the angle now. IKJ. Find that angle. IKJ. So IKJ, this angle here. Whoa, kids. Before you guys start busting out sine, cosine, tangent, I thought I mentioned we can only use that in a right triangle. Not any triangle, only a right triangle. I don't see any right triangle. Oh, we know our properties, and rectangles have right angles. There you go. Look at you guys knowing something. All right, so what sides do I have now? Now we can talk. Sine, cosine, tangent. What sides do we have here? Oh, there we go. Lauren, how about the 32? Yep. How about the 11? Adjacent. Good. So it looks like we got cosine going. Cosine. Cosine of the angle. Adjacent over hypotenuse. Again, no cross multiplying when you find an angle, only a side. Only cross multiply when you find a side. So second shift cosine. So what angle has a cosine ratio of 11 over 32? Nearest degree when you have it. Nearest degree. Jonathan? 70 degrees. No?
I just didn't get that.
User error?
I think so.
Yep.
Yeah,
Most likely.
probably.
Shift cosine. 11 over 32. Yep. Anybody else? We good? This next problem makes me so happy because it's going to make you so miserable. First, the directions we got to talk about. Solve the triangle. Solve. What do you think I want out of that without me telling you? Solve. Any guesses? Thank you. Yes. Find all the sides and angles that are missing. Yes. Let me say that again. Find all the sides and angles that are missing. Oh, that is great. That's not great because I'm lazy. Find all missing sides and angles. Yes. So you're going to see that tonight on your assignment too. So anything that's missing, it could be worse. All right. How many sides are you missing? One side. Can we find that first? Do I need sine, cosine, tangent? No, thank you, because you're remembering everything from this unit, and I still have what available? Hey, Pythagorean theorem will find the missing side. And by the way, you can't use sine, cosine, tangent yet. You don't have enough. You don't have an angle to go from. So if you chose to find the side first, it's going to be Pythag. All right, can you plug that 21 and 25 into Pythag for me? Whoo, Stephanie, where's the 25 go? Darn right. And then 21? Or B, right? Yep, either one. Your choice. All right, so you're solving for A or B. And yes, this won't be a pretty whole number. So that's why I gave you the rounding directions to the nearest tenth. Oh, I love it. All right, what'd you get for that side, nearest tenth? Oh, Vinny? 13.6. Good. A reminder: if you use that answer coming up to find either of the two angles, the non-rounded version, right? If you're going to use that, I'm going to use probably 21 and 25, so I don't have to keep writing that all out. All right, so we have two more angles to find. Your call. There's no wrong answer here. Do you want to find angle A or B first? Your call, Shar. What do you want to find? A? You got it. All right, everyone, here we go. Let's find angle A. I'm going to use the two sides I was given, 21 and 25. Again, because I don't want to use the non-rounded version and keep writing that out. So I'm going to use 21 and 25 here. So what sides are those to angle A? Opposite, adjacent, hypotenuse. Shoom. Dylan, back to you. What's the 21 from angle A?
Opposite.
That is the opposite. And how about the 25? Yep, watch your mouth. Hypotenuse. So we can use sine here. All right, we're going to use sine to find angle A. Okay, don't forget what we were taught today. So sine. Now, hey, you want to put an X here, put an X. I'm going to put A for angle A, but whatever you want to use, equals opposite over hypotenuse. No cross multiplying. No cross multiplying needed. I asked the calculator what angle has a sine ratio 21 over 25. And when I round that to the nearest degree, angle A, when you're ready there, Makai, 50, what?
Oh, the nearest degree, 57.
Thank you. 57 degrees. And then, hey, can we work smarter, not harder, to find angle B? Do I need to use sine, cosine, tangent? Could I? Yes. Do I need to? No, because you have 2 out of 3 angles of a triangle, which means to find angle B, I just need to take 180 minus the right angle minus the 57 we just had. Which one? That's going to be 33 degrees. Now, hey, if you wanted to use sine, cosine, tangent, you're still going to get 33. All right, just a different way of going about it. And how about we finish it up with the word problem with our boy, Big Al. He's got his good old ladder with him once again. Let's see if you can set this one up on your own now. I just want to see the diagram. Let's see if you can draw the diagram, because that's half the battle. And that ladder's leaning again. It's leaning, not vertically or horizontally. It's leaning up against the house. That's cute. All of you guys making it look like a ladder, making it look like a house. That's cute. I'm just going to draw a right triangle. Yeah, put your little rungs on there. Yep, that's cute. Yep. Put the roof on the house. Beautiful. Don't want any rain to get in. Yep. All right, so hopefully you're putting 18 on your ladder. 6 feet from the base, so hopefully you're putting the 6 on the bottom, because I put the word base of the house 6 feet from the base, the bottom. And what angle are we looking for out of the 2 here? Well, I tried to do my best here to say what is the angle at the bottom of the ladder and makes with the ground, so you knew exactly where to put that. Ground, bottom of the ladder. There we go. So what sides do we know here? 6 and 8. What sides are we working with? Alexi? 6 is? And 18? Darn right. So we can use cosine here, everyone. Cosine. Keep reminding yourself, I'm finding an angle. I'm finding an angle. No cross multiply. Don't cross multiply. All right, what angle to the nearest degree has a cosine ratio of 6 over 18? When you're ready there, 1 6. Bryson?
71 degrees.
71 degrees. Questions? Okay, part of the homework is 1 question on the next page, and the rest is in the textbook. Go to that next page for me so we can help you to be successful on this one problem, because we got to go over a couple properties here. So this is a rhombus. All right, we're giving you a rhombus on this one. I'm not doing this one with you. I just want to remind you of some properties that'll make you successful here. And I believe they give you the diagonal lengths, right? 12 and 16. All right, before I draw in the diagonals, it asks for find the measures of the 4 angles. So here's I'm looking for what these measures are for my final answer. All right, so before I draw in my diagonals, that's what hey, and even before we start here, you know something about these angles up here? What do you know about the opposite ones? Oh, boy, it hasn't been that long. Rhombus, what do we know about the opposite ones here? They're congruent to each other. And what about the consecutive ones? Supplementary. So what am I trying to get at here, kids, is, hey, you find one of these angles. You don't need to do anything else to find the other three. The opposite one is congruent, and the consecutive ones are supplementary. All right, so you do not have to find all four separately. You just find one, and you got the rest of them. All right, so how do I find just one of them then? All right, draw on your diagonals. All right, more properties. What do we know about these diagonals we're drawing in? It's a rhombus. What do we know about these diagonals? Perpendicular. Hey, I got my right triangles now. I can do sine, cosine, tangent. What else do we know? Bryson.
They bisect each other.
Okay, so instead of 12, 12, what can we put? Oh, no, I'm sorry, 12, we can put 6, 6. And instead of 16, we can put 8, 8. And you're missing another big property that we rarely use, but it's going to help us in this one. Because remember, I got to find the full angle eventually. Anybody remember something else? Vinny, the diagonals?
Diagonals bisect.
Correct. So here's the deal, and I'll let you go after this. You find that angle using sine, cosine, tangent. You know the angle next to it because they're congruent. And then remember, opposite angles are congruent, consecutive angles supplementary. Right? So you don't have to do that much work here. You just I think you just have to find one angle and then go from there. So there should only be one sine, cosine, tangent equation you're solving. And then you can use all the rhombus properties from there.